Okay, we've heard a lot about all this awesome event sourcing stuff. Now get back to Earth. Uh, get back on Rails. So we start as I promised. We start with these pictures, and 82 people leave their responses, and I want to say thanks to all of them. Now we have this data, and we have some stuff to think about, and I think it's really interesting. So 66% of the people are happy with Rails, and I'm a little bit surprised about it. And it means either you're much much less critical to your code than I am, or you're much you do know how to manage complexity much better than me. Then I don't know why you're not staying here and I'm staying here. Or like another option is that it's Wroclaw, and like you already know how to deal with Rails and how to manage complexity in Rails. All right, so yeah, this is like obvious. If you every year tell people what DDD is, you can expect that they know DDD, at least familiar with it. How people manage complexity. So almost, not almost, 81, 82% people do additional layers and building blocks, and only 20% do frameworks on top of Rails. Nick for sure could improve his marketing here. And what surprised me is that someone actually thinks that if he uses Rails engines, then he manages complexity. Yeah, and the two last answers, they are actually fake. I don't think you manage complexity by moving stuff around. So I mean, the numbers are real, the options are fake. And then, what kind of non-MVC classes do you use? Almost all people who answered use services, and well, you see the picture. So what surprised me is that a lot of people use repositories. I would really love to see how they look. So if you, I don't know, I'll probably ask the people who answered like this to show me their code, because I'm really interested how your repositories look like in Rails applications. And the most like like love-hate relationship is device. So only 40% of the people think it's a good thing, and 36 think it's an evil thing, and the rest, like, it's all complicated. All right, we can now get back to the topics we wanted to discuss. And I want to start with callbacks in our models and another graph. So again, how do people use callbacks? How do people do not use them? And I want to start with this small example, which is a little bit weird, but I just found it on the internet yesterday, and I found it would be funny to show it. So the intention here is actually good. So the intention here is to have a default value for the gender. But what can I do with this code is pretty strange. So I create a new object, I put a gender there, then I ask if the object is valid, and then the gender is changed. So what kind of comment query separation is this? What are we talking about? So if we write code like this, we will never be able to use models like if they would be our domain models, because we do care about the we only expect object to be valid, I mean ready to use, after it's saved. So there are two states of the object: until it's saved and after it's saved. So we rely on this and explicitly use this in our code. So that's a bad thing. And that was a simple case in, like, you know how it looks like in big applications. All right, so what can we do here? Let's look at it one more time. And we know where to put defaults in Rails, right? So we have migrations and we can put defaults there. But the trick is that it's not the best idea, actually, because defaults is your business logic. And if you put it in two separate places, into database and into the model, then you keep the same kind of information in two different places. That's not a good thing. So the change is trivial. Apparently you can use constructor in active record models like this and put defaults there like this, and it simply works. So this is how you can throw away at least part of your callbacks from your models. All right, another example. It was also found on the internet. So here we have a geocoder gem, and the code looks very simple. And guess what happens when we ask if the room is valid? Request goes to external service. So we wait while the service responds, and then the state of the object again changed. And we just simply asked if the object valid. And it is supposed to be our domain model. What could go wrong? And the reason for this is simple, is that the author of the gem in his README, the first way how to use his gem, he describes that you should put this stuff into model. So I agree that this is really hard to resist and not to put this into model, because the guy with 5 stars on GitHub says that you should be doing this. Who am I and who is this guy with 5,000 stars? So yeah, and the bad news, you can't trust anyone on the internet. So even if they have 5,000 stars on GitHub, even if they have a beautiful landing page about their gem, it doesn't matter anything. So you had to develop your own reasoning about stuff. Good news, it is possible to learn how to make your own decisions, and this is what we are trying to do here. All right, let's take a look what we could do here. So we know that we have services layer to deal with external services, and we simply call this geocoder explicitly with the address, and we get the data out of this service, and then we put it into our database. So does this look good now? What is wrong here? So let me show you. So services are about business logic. We agreed on this, right? This second line in the service, is it a business logic? Is this information a part of our domain? Yeah, it's about persistence. It's about how we put stuff into active record. So we have active record, and it's convenient to work with active record. This is why we still use it, but it's not our business logic. So this is where another layer comes out, and the name of this layer is mutators. So what is this layer for? So we're gonna be using this layer for the single purpose. All the operations like creation, editing, and deletion, we will put them there. So we simply take this line of code and put it into the class and into the method, into the class method of the room mutator class, and call it from our service. So now service contains only business logic. It goes to the external service and takes information from it, and it puts it into the database, and the rest is handled by this mutator. That's the idea. So because on this level of abstraction we are not interested in the details, we just want it to be stored somehow, and we want someone else to care about how to store it properly. That's the idea. So is it okay to use at least some of callbacks? Yes, you can use callbacks like this. So if you want to cache some counters or do some denormalization while creating something, you can do something like this. But there is a way to improve this. The next step to improve this is to add this line. So it's okay to keep this for a while in the model, but when it becomes more complex, just move it to the mutator layer as well. All right. So previously, yesterday we had a service like this. So in order to store something into database, it had to do a lot of stuff. So, but again, it's just an active record stuff, and it can be simply moved to the mutator completely. What I love about this schema is that it allows you to be lazy. Let me show you. So in the simple case, we can do everything in the controller like we usually do. We simply create an object. If it's valid, we save it. If it's not valid, we render a form. Then in a more complex situations, then we create a service and put our logic there. Or if the logic is only about how to put it properly into database, we create a mutator and call it from the controller. Or if it all goes completely wild, then we can create a service which can call different mutators, can call different external services, or trigger a job or something like this. So here's an example of such a service. And this is what I don't like about Hanami, is that in Hanami you have to create all the boilerplate code up front, so you can't be lazy in Hanami. All right, the purpose of layers. First of all, models. We try to treat them as domain models, and they contain relations and business rules. And also important about models, since it's a domain model, there are no such thing like ID. So because ID is an implementation detail, and there shouldn't be no, like in services, you shouldn't be passing IDs. The only one place where you are allowed to pass IDs is when you trigger a job, because you don't want to push the whole model into the job. Mutators, they handle creation, editing, and deletion logic, so that we are always operate with objects in correct state. Those are supposed to be atomic operations. Services, they handle business logic and interaction with external services. And controllers, as usual, application logic, like additional form fields, sessions, flash messages, and redirects. All right, let's talk about form objects. And here's the picture from survey. Most of the people use form object. Half of the people here, they use them a bit. And well, you see the picture. 23% people use them a lot. And where do we need them? Where we have some additional stuff which doesn't play nice with the default active record way. So for example, in this form, we not only register a user, we also want to create a company. Or here, so this, in this case, we only want to save one date, like when warranty is about to expire, but the form looks more complex and we need to make sure that everything works fine. So it's not obvious how to make it work in Rails way by default. So there are different hacks, and people are very creative when it comes about form objects. So I have like this list of links on different gems and different approaches and how to build your own form objects. So it really shows that there is no single standard. And well, there's still like a typical way of doing form objects. This example was shown on this famous article, like 7 ways to do something with your active record models, to decompose fat active record models, right? And the bad thing is that this doesn't play well with nested attributes. So, and the author of this, I forgot the name, the guy from Code Climate, says that, well, you simply don't use it because it's a bad thing, but it's so handy, and it's a bad, sometimes we need it. And another bad thing that we construct the whole thing from scratch. So again, it feels like Hanami. This is how we use it. This is a good part. So in controller, it looks like a model. We simply call it and save it, and we are fine. Yeah. And the same example as yesterday. So we can have like if we have 2 different contexts, and in a moderation context we want to make sure that the publication date is set, then the Rails way solution is conditional validations, but it pollutes our models with a lot of conditionals, and some of them are form-related conditionals, and in our models we shouldn't have form-related conditionals. So the fix is very trivial, actually. So I was shown a way how to create very simple form objects. It looks like this. So all we do, we create a concern, and we define 2 delegators there, and to make Rails think that it works with the same model. So in this example, we have article, and now we created moderation article form. I named it form because like it's not a real form, right? It's more like a model, so it's a kind of fake form, but we still want to name it something like form. I was thinking about name shape, but this I like more. So we put additional stuff like validations or different attributes in this form, and we simply call it as usual in our controller, and it simply works. This was very surprising to me when I seen this for the first time, but it just works. Well, you need to put a bit more stuff inside if you want to make it play nice, like in all the cases with Rails. But still, like, you simply put this code snippet into your Rails application, and you can do like this stuff, and you can have forms almost for free. Alright, so they have 0 maintenance cost. They bring you no new abstractions. we were talking that we will try to use Rails defaults as much as possible. This is definitely within Rails way, and it plays nicely together with controllers hierarchy. This is another nice part. So you remember we wanted to build the hierarchy thing, and so we have this name, moderation article form, and we have the same hierarchy in the controllers, moderation article controller. All right. Yeah, and of course it's a dirty hack. So, but as we agreed, if a dirty hack allows us to build a good system, then it's more than okay. All right, the next thing. Flags as a sign of implicit state. This is the code I written. So I was implementing the subscription page, and you know that it can be tricky because when you need to care about subscriptions, like you first take credit card data, and then you want to the month passes, you want to take money from the card again, and then something goes wrong with this card, then you should probably cancel the subscription, or person cancels his subscriptions before before it ends, and we still need to give him the ability to use our website. So we need to handle a lot of different scenarios and show different information. So I've written the code like this, and at some point I stopped understanding what's going on there. So it stopped working, and I didn't know what is wrong there. So what is bad here is that I use random methods like this, and I try to figure out what's happening here depending on these let's call them flags. And there are gems to standardize this. So gem like flag shih tzu, it allows you to define your flags in your model, and gives you a bunch of handy methods like this. And it is also supposed to be a good thing, right? So you have a standard, and actually this example I found from the one Polish guy blog post, and he said that Boolean flags are an inseparable element of most Rails application. They control various aspects of the model business logic. So, and maybe some of the flags are okay here, but the second one looks suspicious to me, because this onboarded flag, what is wrong with it? So it looks like this flag defines state. And if we use flags to define states of our objects, then we are gonna be in trouble. Let me demonstrate this. So I took, let's say we have 4 flags like this. So if trial expired, if something expired, if subscription canceled, if subscription expired. Those looks really strange to me, but let's say like that's not that important. So when I introduce flags into my system, well, how many combinations do I get here? So let's say those are binaries. So we have this nice table of combinations, and we have 16 combinations. And when you introduce flags like this into your models, you don't expect to have 16 combinations, but you have. So this is combinatorial complexity explosion, and this is why you shouldn't be using flags for managing the state. So not managing the state, it's like, well, let's dive into it a little bit later. So what we have here, the problem is that it's not that easy to identify those flags sometimes. So here they are hidden. Those flags, they can be dates, they can be some periods, they can be associations, like my model has some association or doesn't have, and I rely on this, and it's also should be considered a flag. Somehow we sometimes we have these status fields. Yeah, so these are the examples of the hidden flags. And the humanity actually invented the solution for these kind of problems, and the solution called state machines. And the state machine defines system behavior in different states. So what was implicit before, state machine makes it explicit. So, and this is an example of state machine, pretty simple one. You see that the system can be in 4 different states, and there are different ways to bring system into different conditions. And another example of pretty simple state machines. And yeah, so the question is, when do we need the state machine? When system behavior depends on its state. So, and the trick is that almost everything in software engineering can be, I think not almost, but everything can be described with state machine. And like we always program state machines. This is, for example, a state machine of Docker. It is a bit more complicated, but still a state machine. It's a bunch of states, transitions, and some rules connected to these transitions. So how it looks like? I bet you know how it looks like. So this is an example how it could look in your model. And this is how your views start to look like. So you specify all the states, and now you rely only on the states. And you know that in how system should behave in every state. So it becomes explicit and it's defined in your model. All right, explicitly defined states and transitions. It prevents combinatorial explosion. You can even have multiple state machines per model, and sometimes you need it. And this can be done with this gem. And yeah, this is how people answered on the question whether they use state machines. So half of the people don't use them. All right. The next thing, if statements through the whole app. This is the interesting topic, and I found an article from it was written by a guy from TopTal, and he showed this example. So this was shown as a example of bad code, which, like, the statement was that we have too much logic in views, and the solution looked like this. So we take this current user and like create a method in the controller which does something like this. So we get the idea. So we create if there are no real current user, we create a fake object, fake OpenStruct object. So what we got, we simplified the view, but the problem is that we just moved this non-beautiful thing from one place to another and make it even more ugly. So the solution here is null objects, surprisingly. So what we can do, we can simply create a plain Ruby object, call it guest, and define all the methods we have in real user object, and make this kind of stubs there. So there is no ID. It responds false to question if it's an admin. It's not a moderator, but it's guest. And so on and so on and so on. And there is his name. And in the controller, we try to find a real user first. If we are unable to find it, we create a guest object. And then we have this beautiful thing in the view, and that's it. You get polymorphic behavior like almost for free. And the trick is that it's not the only scenario where we have behavior like this, where we tend to use if statements. Like, they are all over our applications, and it's not only about users, but like another example where you should be considering creating another object for another type of user is when in your system a user with an age under 18 behaves differently than a regular user. Then it should be a separate model. It wouldn't be a null object, but it should be a separate model. Alright, null objects explicitly define different types of entities in our system. You get polymorphic behavior for free. We get logicless controllers and views. And the bonus here is this simple gem that was created during the workshop I attended. So what it does, it allows you to so you simply include it into your object, and then you can do stuff like this. So you if there is no, so let me show you too many stuff here. So for example, of course, the object responds to all this stuff, but the interesting part is that if we ask for an address, for example, it returns nil. If we ask for posts, it returns an empty array. So for all methods which are not defined, it like gives you a stub. It responds to false, nil, or empty array, depending on the name of this method. So this is pretty handy, and you should be using this. And still, like half of the people don't use this trick, but you should be. All right. The next thing, we postponed the talk about models, but models are crucial, and good models are beautiful and lean and make us happy, and bad models, they make our life as a developers miserable, because because we don't think about our domain, we think about other weird stuff. So what are these models? So these are like a heliocentric model of the solar system and heliocentric. And you should know this guy. And this is Nicholas Copernicus, and I know that there is an airport nearby named in his honor. And he was advocating for heliocentric model of our solar system. But there is another guy. And this guy named Aristarchus of Samos, and he lived even earlier. And the trick is he had this idea of heliocentric model even earlier, much earlier. And so I'm not sure if there is an airport named in his honor as well. But what it means for us is that even the whole world, or in our situation, the whole Rails community, keeps putting everything into models. We don't have to repeat after them. That's the idea. And yeah. So I know, I hope it will be hard for you to keep doing things in the old way, in the old active recordish way. And the good news is that you now know how to reason about this kind of stuff. And yeah, you're welcome. Welcome to the real world. I should have been asked if you want this blue pill or red, but I forgot, sorry. Yeah, so what stays in the models? Associations, business rules, state machines, defaults, and the question is, what about scopes? So if the model is big, if the application is big, then we might have like tens of these scopes, or probably, I don't know, hundreds maybe, I don't know, never seen something like this, but who knows. And scopes are usually on the top of our model, but they are not actually about our domain logic, right? Those are like a kind of a shortcut to a way to get the data, to get the data sets, or like sets of our objects or something like this. So this actually looks like repositories. And there is a simple way to get rid of the scopes in our models. Again, we use dirty hack. We create a concern and we put our scopes there, and we simply include this into our model. And both worlds are happy right now. Rails keeps thinking that scopes are inside, and we should be happy as well. We have a separate place for the definitions how to get data from the database, and we have clean models right now. That's perfect, I think. All right, an example of the model. So the question is, what stays in the model? So associations, state machines, and a little bit of business rules. So you can have more of them, like, and we see that stuff in null objects. So you can have more methods like this, but that's actually it. And let's take a look at this beautiful schema. So I should have been draw something more like this, like the circles, right? It would be more correct. So this would be our models, and it's just weird. So models and like repositories nearby. Then we have the mutators part. Then we have our services and the controllers, and somewhere like views and external world and all this kind of stuff. And again, so this schema gives us pretty straight idea of who could do what. And so, for example, models. So the question is it okay if I call a service from a model? Is it okay? No, it's not, because it's like, is it okay if I call a service from mutator? No, it's not okay. So this schema gives us a lot of answers, and this is pretty clean, actually, I think. All right, I have a lot more slides about testing. I'm not sure if we want to go in this topic, actually, because I could create like a separate talk about this, and I feel not very like confident in this area, actually, and I think someone could do much better than me. All right, let's jump into it as well. So the question is, do we really need to cover our application as much as possible? The trick here is that the situation with tests is very similar to the situation with the hosting when it comes to the hosting uptime, hosting services uptime, and the same as it goes with web performance, web pages performance. So we can easily achieve like a good enough results, but the more reliability, the more performance, and the more coverage we want, the bigger price we should pay. And the question is usually, what test should I write? And I know that a lot of people, they've been taught that unit tests is a good thing, and they tend to do it a lot. Yeah, but some people, like, then they have problems, because when you cover everything, like your models with unit tests, then you have to maintain them, and they're usually not that stable, they are usually fragile, and you have to support them, and people think that, well, I had enough, and they go to the opposite direction, and they go into acceptance testing. So now they doing another thing. So now they write in another kinds of fragile tests. You rely on the ID of the div block, which is being loaded by some AJAX call, and it's not very reliable. So, and we had a great conversation yesterday with Nathan, and I really liked his model about how to reason about what tests to write. So the idea here is that you can go either in deep or you can go wide with your tests. So, and you can put so you can think, where are the models on this picture, where are the acceptance tests, where are the controller tests, and so on and so on. So with model tests we try to go deep, like we try to cover our core logic with the tests. With acceptance tests and functional tests we try to go wide, and this is what we want actually at the beginning of the application, and this is what you have answered. So most of people do unit tests, and surprisingly big amount of people do acceptance tests as well. So what are the right questions when we are about to write tests? The first of all, are they useful? Are they easy to write? Are they easy to support? How fragile they are? And how often do you need to rewrite them? Yeah, and controller tests here is the most low-hanging fruit you can get when you're about to test your application. Because all you want to do is to make sure that every endpoint of your application was touched. So every action, you touch every action in your controller, and in a simple case you just check if the response is successful. If it's an update or creation or deletion, you need to make sure that with correct parameters the correct stuff was made. So these tests, they're easy to write, so they not that you don't need to change them that often, so they have the maximum return on investment, I think. And this is the first thing you should be doing in the new Rails application. Then you have to think, you might want to test services and mutators, because they are important. This is where you go in deep. This is where you cover with tests your core. All right. Another thing. This is another low-hanging fruit when it comes about tests. And the rule number one, always use named roads. Because when you use strings, sometimes we are too lazy to go into routes and check out what is the name of the route, and we use strings. The problem here is that when we use string, then if we made a mistake there, then Rails will not give us an exception about it. So that's the problem. So we will not notice this in our test. We will not notice it in the development. This is the problem. the same story goes for rest of the strings in your application actually. So the advice is to use internationalization even if you have an application with a single language. And there is enumerize gem for enum fields in your models. And there is a handy trick. I'm not sure why it's not in the Rails yet. But I don't have a snippet here, but idea is also simple. So instead of doing this flash success equals something or flash notice or something like this, what you can do is to create a simple helper method. You can call it F by analogy with H. And what it does, it takes the current path to the action in the current controller and goes into the internationalization file, and it takes this parameter, success or failure, and it takes the corresponding message. So this is how you can get rid of strings from your application. And what it gives you is that when you run your functional tests, then your tests touch even more stuff. So your controllers, they call services, services call models, and in models, you also touch this kind of stuff. All right. Now we getting close to the most holy varish themes, and the themes were at least prepared. So, but I think we should like go through this as well. So at least you will have a reason to have a conversation in your company about this. So people by default use RSpec. This is like this is an agreement. We all agree to use RSpec. Still, I think it's overvaluated, and why do we love it? We love it because of semantics. We have this subject, describe, it, expected to, nested context, and all this kind of stuff. The problem is that in the big application where the test suite is complex, it's hard to structure the complex text. You don't know how to do this nested stuff properly. You can even have like conversations about how to do it properly. Like you can spend days on this. And yeah, and the last part here is that these shared examples, I don't think they work for anyone, but they are there. And the second thing we love about RSpec is matchers, and we love doing things like this. We love a lot of matchers around, and I think this is how it feels when you finally found the perfect matcher or implemented your own matcher. So this is how it feels like. And I think we tend to value pragmatism over aesthetics more in this situation, and compare this to this. We were completely fine with the first option while we were writing like a regular code, but in the test suddenly we need something like this. So this is a bit strange. And yeah, the worst thing about RSpec and about libraries like this, about device, about ActiveAdmin, is that the subject, the complexity the framework creates is significant, and you have to spend a lot of time learning how to deal with it, but you can reuse this knowledge outside of the ecosystem. So you can like learn device in depth, or can learn RSpec in depth, but you still can't reuse this knowledge outside. So alternatives mini test, it does its job. It's much faster. It has low-level semantics, but it's much familiar, and it's simpler than RSpec. And another cheap solution for cheap replacements for custom matchers. There is a gem called Power Assert, and here's what it does. So you simply use curly braces and you put the thing you want to test, and when your test breaks, then it gives you these nice kind of reports. So you see what kind of stuff happens there, and I think it's much more useful than you expected, I don't know, 40 and get 42. All right, factories versus fixtures. The same situation. People use factories by default, and with factories, they're slow because they recreate the whole universe every time, especially in the big application with a lot of associations. You can do cross references, so you need to hack around. And fixtures, I think they're undervaluated because they're fast. They support cross references. In most situations, you don't need a custom user or a custom object. You are fine with a standard user. You don't need to recreate a custom thing. You don't need to support like a separate branch of creation process in the tests. You just pick the stuff from your fixtures and work with it. And the handy trick is that you can load them into your development database and work with them. So if you do, so you did that, you do some exploratory testing, and you found some interesting scenario, and instead of keeping this database forever, this development database, you just go and fix your fixtures. I mean, you add another fixture for this scenario, and you again load your database, load these fixtures into your development database, and you can keep doing with this kind of stuff. So that's a good thing. There is a gem that allows you to use factories like fixtures. So it's the intention is to fix everything with another gem. I don't remember the name, but you can Google it, I guess. And the last topic is mocks versus stubs. Really short here. With stubs, you replace external stuff, like external services. And with mocks, you test your tests, they become dependent on the internal structure. So instead of testing black box, you're starting to test white box. And this is what you should avoid if possible, because with mocks, you can't replace the implementation. You start be dependent on the structure of the things, on the thing on the test. All right, so the final summary. So how do we make our life harder? We prefer easiness over simplicity often. We prefer aesthetics over pragmatism. We prefer popularity over thoughtful analysis. We prefer conventions over criticality. So I hope that we'll stop delegating the process of decision making to random or not so random people, and we'll learn how to do it ourselves. And apparently the conclusion is the same as Nathan said yesterday about event-based stuff. So ideally we shouldn't be allowed to work with Rails until we understand how it works and how it should be working, but reality is different again, and you have to decide what to do with this. So I hope that my talk will trigger some conversations in your company and some experiments. And if you don't have questions again, then I consider my job done well, because it means that you're in the state where you have more answers to the questions But if you have questions, I'll be happy to answer them. And I don't know how about you, but I'm personally happy because I finally can finish my book and cross out this to-do item I had for years. And if you're interested in this, you know where to leave your email. And also I had the idea that because like for me to get all of this, to go through all of this, it took 2.5 days of not only of theory but also of practice. And I think it is important to get a bit of practice to get a feeling of it. So I think for those who left the emails in this survey, I will prepare small tasks so you could create a few like services layers, like mutators and services and this kind of stuff. So you will learn it and you will understand the concepts a little bit better. So that's it for me, and thank you.